All right, 3.6. Last class we closed out 3.5, in which we talked about asymptotes. So we're looking at 3.6 today, and we're looking at polynomial and rational inequalities. Don't forget our inequalities are these symbols over here: less than, greater than, less than or equal to, greater than or equal to. Yep. So those are inequality symbols. I don't know why I erased that. Keep that up there. All right, so looking at a quadratic inequality. Up to this point, we dealt with quadratic equations. Remember, equations have equal sign. Inequalities have your inequality symbols. Once again, one of these symbols right here. So now looking at our quadratic inequalities, what we're going to do is examine our parabolas to help us have a better idea of what's going on. Don't forget your parabolas are going to be concave up or concave down. We talked about that before. So we will have these points right here. At those points, that's when your parabola or your equation is equal to 0. So everything above that point will be positive. Everything below that point will be negative. So we have these intervals right here. From there, from negative infinity to that point will be positive. From this point to this point, it will be negative. And from this point to this point, it will be positive. So that's how we're going to set up our intervals. Once we put numbers on it, you'll see what we mean, and it'll be, a better visual. But just trying to give you an idea as to what's going to happen. We're going to have our graphs, our quadratic equations. They're going to behave a certain way. They're going to either be positive or they're going to be negative in these intervals. And that's what we're going to use in order to be able to determine what our answer would be. All right. So let's look at the first one. We have 2x squared plus x greater than 15. All right. So see, the first move to make is to set one side equal to 0, because we want to be able to compare our expression to 0. You'll see why in a second. So we subtract 15 from both sides. Our new inequality is 2x squared plus x minus 15 is greater than 0. All right. So the reason why we want to compare our expression to 0, because we want to know when is 2x squared plus x minus 15 greater than 0. So there are only one type of values that are greater than 0. Those are positive. If it's less than 0, then they are negative. So we want to know, see what I have right here in this red circle, when is the equation, or I should have wrote expression, when is the expression positive? When is the expression greater than 0? All right. So in order for us to establish when it's greater than 0, we first want to know when is it equal to 0. So we want to solve for when the equation is equal to 0. Remember, those would be those points that I was mentioning. That's where these points would be, where it's equal to 0. So I decided to take 2x squared plus x minus 15 and factor in order to solve. Remember, if you're not comfortable with your factoring skills, that's fine. Just use the quadratic formula. Either way, you still should get 5 over 2 and negative 3 as your solutions. All right. Any
Could you go back up for
questions?
1 second, please?
Did I go up far enough?
All right, I'm good. Thank you.
Mm-hmm. right.
Perfect. Thank you.
All right, not a problem, not a problem. Any other questions before we go to the next step? Make sure we're okay. All right, so make it a little bigger. So we have our two values. We use those to help set up our intervals. So of course, -3 comes first on your number line, then 5/2, positive 5/2. So we have these intervals here. -infinity to -3, -3 to 5/2, and 5/2 to positive infinity. So we have three intervals. So what we're going to do is create this chart. I'm going to erase this stuff so that we can walk through the process. All right. So it's not mandatory that you create this chart, that you make this chart, but it is or will be in your best interest, I believe, to help you stay organized and to find your answer. So notice we have your interval. Where's my color? We have our interval, then we test value, and then behavior of the graph or behavior of your function. So those are the three rows that we want to create: interval, test value, and then behavior. In the interval, we already discussed what our intervals will be: -infinity to -3, -3 to 5/2, 5/2 to infinity. So now we need to put our parentheses or brackets where they're needed. Don't forget, infinity signs will always have parentheses. So don't forget the meaning of your parentheses, brackets. Parentheses mean that you're including the value. I mean, not including the value. Bracket means you're going to include the value as a part of your solution set. So what dictates whether we use our parentheses or bracket? We go back here, and I wrote it right here. If we have a greater than or less than symbol, it should be parentheses. Greater than or equal to, less than or equal to. I keep saying greater than. This is less than, sorry. So less than or equal to, greater than or equal to, we use brackets. So it's this equal to symbol. The little bar under it will let you know if you're using bracket or not. So here we should be using parentheses. So use parentheses on each one of your numbers. Any problems? All right, so now we need test values. So you want values that are in the interval. It doesn't matter what values you use, you're still gonna get the same result. Now, we're not gonna focus on the number. We wanna know, is it positive or negative? And I'll show you what I mean in a second. So I'm gonna use -4 here. Anything that's less than -3 will work. So if you wanna use -100, it's your prerogative, feel free. I'm gonna use 0 here. Anything in between -3 and 5/2. And then anything greater than 5/2, I think I use +4. Let me see in my notes. Yeah, so I use +4. So once again, anything in those intervals will still work. All right. Once you establish what your test values are, you plug them in. So that's what I got right here, plug in your test values. I decided to use my factor expression just for easy calculation. If you want to use your original expression, you can. Remember, we're not focused on what number you get. We're focusing on, are you getting positive or a negative number? Because that's what matters. Because if it's
Quick question,
positive,
Professor Tucker.
yes.
About the test values, can you just slowly repeat so I can note it down? For the first one, for the -infinity to -3, is anything below the highest number?
Right, -3.
Okay, anything below the highest value. And for the middle one, it's anything between two values. And for the last one, anything below the highest value again?
Above the lowest value. You talking about a 5/2?
Yeah,
Above.
anything above the lowest value.
Mm-hmm.
Anything.
So you want something that's greater than 5/2 for this last one, something in between -3 and 5/2 for the middle one, and something less than -3 for that one farthest to the left.
Something less than the highest value, yeah.
Mm-hmm.
All right, thanks, Professor Tucker.
Not a problem, sir. Not a problem. Anybody else before we go plugging in these values? All right, so that's what I did here in the purple. So looking at the first one, like I said, I decided to use my factored expression. If you want to use the original expression, your results are going to still be the same. I plugged in -4 here. That ended up giving me a negative number times a negative number, which is the positive result. So any number that you choose in that interval will yield a positive result. Plugging in 0, I end up getting -5 times +3. So a negative number times a positive number is a negative number. And then plugging in +4 down here, end up giving me a positive number times a positive number, which is positive. All right, so let me know if you have any questions on what we've done up to this point. I'm sure we're all right. All right. So how do we figure out what our answer is? We have a positive, negative, and positive. We go back to our original expression where we're doing our comparison here. And remember, we wanted to know when was our expression positive, greater than 0. So you go back to the chart, look for our positive scenarios or positive outcomes. And that's our answer. -3 to negative infinity to -3, 5/2 to positive infinity. All right, so let's see something in chat. All right, somebody need to scroll up. Let me know if I went up high enough. Yep, not a problem. All right, any questions before we try it again? All right. Oh, I know somebody's copying. Are we good to scroll up? Let me know. Good. All right. All right, so next one, x cubed plus x squared less than or equal to 4x plus 4. So this is our original inequality right here. Once again, notice that we do not have one side set equal to 0. So we want to set one side equal to 0. And that's what I did here. I subtracted 4x and subtracted 4 from both sides. And that gave me x cubed plus x squared minus 4x minus 4 less than or equal to 0. And those we have less than. So this time, you see right here, I have it in red. That means we want to know when is this expression negative. Before we had greater than 0, so we're looking into when it was going to be positive. This time we're looking at when is it going to be negative. All right. So just like before, if we want to establish or figure out when is greater than or less than 0, the first thing we want to know is when is it equal to 0. So we can set up our intervals. And so here's the process here in the dark blue. Let me know if I'm scrolling up too fast. Everybody good? Okay. So x cubed plus x squared minus 4x minus 4 equal to 0. So I decided to solve by factoring. So if you have 4 more terms, then you factor by grouping. So that's what I wrote right here, factor by grouping. Group together the first 2 and the second 2. X cubed plus x squared, factored out x squared. Then negative 4x minus 4, factored out negative 4. From there, we have x plus 2 left in the parentheses. So we pulled that out, extract that out, and that leaves me with x squared minus 4 in the other set of parentheses. X squared minus 4 can then be factored into x plus 2x minus 2 by the difference of squares. All right, once you factor completely, set each one equal to 0 and solve. That gives us the solutions of -1, -2, and +2.
Professor Tucker,
Yes, sir.
can you explain how you got x squared minus 4 over there?
Okay, so that's what was left right here. So when we pull x plus 1 to the front, that what's left.
What's left is pulled to the back.
Exactly.
I see. All right, I appreciate it.
Not a problem.
So this might be a dumb question. Why wouldn't it be x plus 1 squared? Because there's 2 of them?
Okay, so it's just like if I had x squared, and that's not a dumb question, it's a great question. So if I had this and I want to factor out y, I will pull y to the front and I'll just have y, x squared minus 4. So in other words, you're not pulling out x plus 1 squared, but you're just pulling out x plus 1. That's what they had in common.
Oh, okay, thank you.
All right, no problem. All right. Any other questions? Make sure we're good before we go to the next step. All right, can I scroll up? All right, so right here, so just a little visual of our intervals. So we're going from negative infinity to -2, -2 to -1, -1 to +2, and +2 to positive infinity. And so let me erase this stuff. All right. So once again, we set up our chart. Oh, hit the wrong button. All right, there we go. So once again, now that we have our intervals set up, we want to establish what symbols go along with our intervals, parentheses or bracket. So you know parentheses go on your infinity signs every single time. That's never going to change. Now, whether we use bracket or parentheses on our numbers will be determined by our symbol up here. That's or equal to, so that means we should be using bracket. All right, so going back, bracket on each one of our numbers. All right, so we need test values now. Anything less than -2, I believe I used -3. Yep, just trying to stay consistent with the notes I already have. -2, -1, so number between that, -1.5. Something in between -1 and 2, 0. Something greater than +2, +3. Once again, you can use any number in those categories. All right, so just like before, I use my factored expression to me for easy calculation. I plugged in those values, plugging in -3 right here. Gave me negative times negative times negative, which is a negative number. Plugging in -1.5 ends up giving me negative times positive times negative, which is positive. Plugging in 0, that gives me a negative outcome. And then plugging in +3 gives me a positive outcome.
Professor Tucker,
Mm-hmm.
shouldn't that be -1.5 plus 2? Shouldn't that be negative over there?
Right here,
Yeah.
the 2 is greater than the -1.5, so that gives you a positive result.
Oh, yeah. Sorry, my bad.
No, you're fine.
I was thinking about multiplication. Sorry.
Oh, okay. Yeah. Anybody else before we finish the problem off? All right, still see writing, so. All right, somebody in the chat. Oh, man. Sorry for giving you too much math.
Pastor Tucker,
Yes, sir.
Basically, the last row with the negative, positive, negative, positive sign, that tells you how your parabola is going to look.
Now, this was a cubic equation. So this one wasn't a parabola. That's why you have more than one solution. I mean, more than two solutions. So I'm going back, I'll come back down for those who are copying. But this was a cubic equation. Remember, your parabolas, your highest exponent is going to be 2.
So it basically tells you how it's going to drop on the grid, negative or positive.
Yep. And see, this is a process that you most definitely will be using in calculus. I know you can't wait to get to calculus, sir. Um, but also, let me point out, in most of the problems that you guys are going to get, this alternation, of your signs will probably be the case. But two warnings on that. First, you don't want to do the first one and then say, oh, since this is minus, that means the next one's going to be plus. But if you made a mistake in your calculation, that means now all of them will be based on an error. So you don't want to do that. So make sure you step through the process properly. But also in calculus, it will not always alternate. So just throwing it out there. But it is a hint as to how this stuff will be graphed and how your graph should look. And if your graph doesn't match up with your calculations, either your graph is wrong or your calculation is wrong. Yep.
Okay. Getting real.
Wait, what are y'all talking about?
He asked, was this pretty much a reflection of the graph and how the graph should fall, and how you should see your graph? And I was just agreeing with him that yes. Yep. And if your graph doesn't match
Negative,
this,
positive, negative, positive.
yeah. In other words, you'll have these 3 points. It'll be negative, positive, negative. So it'll be negative down here, positive, like that, negative, and then positive. So it would look something like that. Of course,
What were you talking about the cubic? Like the first one was a square, cube. It's the same calculations, right? It's the
It's the
same.
same process, but he had called this a quadratic equation, and I was just making sure that you recognize this is actually a cubic equation.
Oh, okay.
Yep. The last one we did was a quadratic, but this one was
That was a
cubic.
quadratic.
Mm-hmm.
Gotcha.
Yep. Quadratic will only give you 2 solutions. This one gave us 3 because it's cubic. All right, so to finish it off, and I saw somebody in the chat said this problem is long. Well, the only reason it's long is because, I am pausing and letting people write and all the stuff like that. Once you get used to the process, it wouldn't take you that long. It wouldn't take you that long. So here we're looking at less than, so we want to know when is this expression negative. So we see right here, oh, not this one. And these 2 intervals is where our expression is negative. So that would be my answer. Negative infinity to negative 2, negative 1 to positive 2. Y'all are funny. Y'all are funny. All right. Any questions before we look at another type of problem? It's going to be the same process, same situation, same scenarios, just that, we're dealing with rational inequalities. So, yep, still going to create the chart, still going to set our parts equal to 0 to set up our intervals. So, don't fret, don't fret. All right, can I scroll up? Everybody good? All right, so let me make sure this isn't an emergency. 1 second. All right, so rational inequalities, once again, you want to make sure that one side is set equal to 0, and we already had that. So we have x plus 3 over x minus 7 is less than 0. All right, so this time we're going to set our numerator and denominator equal to 0 to establish our intervals. So that's what we did here. X plus 3 is equal to 0, x minus 7 equal to 0. Solve those, you get x equal to negative 3 and x equal to 7. So make sure we're all right before we go any further. All right, so it's in the chat. Just find an answer. You shouldn't have to grab these. Just find the answer for the question. All right, so go into our chart. Going to erase it and we'll walk through it. So intervals, negative infinity to -3, -3 to 7, and then 7 to positive infinity. All right, now we can put our parentheses where they are supposed to go. Infinity symbols always catch the parentheses. Then here, because we have the less than symbol, not the or equal to bar, that means we're going to use parentheses on the 3 and the 7. All right, now I need test values. So we got -4, 0, and probably go with 8. Something less than -3, something in between -3 and 7, something greater than 7. All right, any questions? All right, so we plug them in. Our expression is x plus 3 over x minus 7. So I took the -4, plugged it in, you end up getting a negative over negative, which is positive. Plug in 0, that's positive over negative, which is negative. And let's see if I can get, too far up. I've got to put that back. So I'll do it. And then plug in 8, you get positive over positive, which is positive. All right, any questions? All right, so we have our chart filled out. Once you have your chart filled out, you can go ahead and figure out what the answer is. We want to know when this expression was less than 0. In other words, when it was negative. That's right here. And so the interval that matches that is -3 to positive 7. And so you have the answer right there. All right, any problems before we go to the next one? Got at least one more like this, and then we'll be looking to close it out. All right, so the next one, let me magnify a little. So the original is x plus 1 over x plus 3 greater than or equal to 2. So just like before in each one of the examples previous to that, we want one side to be equal to 0. So we need to subtract 2 from both sides. I'm going to erase this, I'll put it back in a second. So don't forget, whenever adding or subtracting fractions, need a common denominator. That common denominator is x plus 3 in this case. So we're going to multiply top and bottom of that 2 by x plus 3. So that creates this scenario for us, and then allows us to combine the fractions right here because they now have common denominators. Then from there, we can distribute. So be careful. Make sure you don't forget to distribute that negative along with the 2. Sometimes people make a mistake and they just distribute the 2 and not the negative. So that will be x plus 1 minus 2x minus 6. In the numerator, combine your like terms. That'll give us negative x minus 5 over x plus 3. So make sure we're okay before we go any further. All right. So let me erase some of this. So we have negative x minus 5 over x plus 3 is greater than or equal to 0. All right. So we're going to set the numerator and denominator equal to 0, just like we did before. So negative x minus 5 equal to 0 will give me x equal to negative 5, x plus 3 equal to 0, x equal to negative 3. All right, I'll talk about this stuff on the side in a second, but I just want to make sure we're okay with getting our 2 values. All right, everybody good? Before we look at our intervals, once again, give me a second. I'll address this stuff on the side. All right, so this is going to help us set up our intervals. We're going to create that same chart, intervals, test values, and behavior. So negative infinity to negative 5, negative 5 to negative 3, and then negative 3 to infinity. All right, so now we want to establish our parentheses, brackets, whatever we're going to use, right? So infinity will always get parentheses. Now going back to our numbers, I wrote it right here. We know we're going to get or use brackets because we have the or equal to symbol. Now we have to be careful here because what does bracket mean? Bracket means we're going to include that value as a part of our solution set. But when I look at x equal to -3, and I look at what happens when I use -3 as x, I get 0 in my denominator. So what I cannot have as a fraction is 0 in my denominator. Remember, that creates an undefined result, or 0 in your denominator is always undefined. And I cannot have my denominator 0. So that means I would actually use parentheses on that -3. Okay? Yes, sir.
In the last problem, we did the same thing, didn't we? We used, if you scroll up, you'll see we used parentheses on -3 and +7. So is that the same deal when we set anything equal to, where like numerator, denominator, we set them equal to, we use the parentheses, and for the upper part where we're just solving it, we used the brackets.
Right. So in other words, your denominator will always use parentheses. Whatever result comes out of your denominator will always have to use parentheses. See, it didn't come up last time because no matter what, we were going to use parentheses anyway because we didn't have the or equal to symbol. So that's why we didn't have that discussion last time. Regardless, we were going to use the parentheses. So now here, because we want to use bracket, we just cannot use the bracket on that bottom because that will give me undefined. I will use bracket for this -5 though. So yes, that top will give me bracket, and then the -3 will use a parentheses. So whichever one comes out of your denominator will always use parentheses. All right. Questions before we go to the next part?
Could you just scroll up just a little bit so I can copy the side notes over here? Thank you.
Not a problem, sir. Not a problem at all. So now that we have our intervals set up, we use our test values. Let's scroll in. I'm not scrolling. Focus in a little bit. Let's see. How about we go -6, -4, 0. Let's see if that matches what I did last. Yep. So I chose -6, -4, 0. Once again, anything less than -5 will work. Anything in between -5, -3 will work, and anything greater than -3 will work. And so I plug those values into -x minus 5 over x plus 3. Doing so gives me plus over negative, positive over negative, which is a negative result. Here, plugging in -4 gives me a negative over negative, which is positive. And then in that last one, plugging in 0 gives me negative over positive, which is negative. And then to finish it off, we were looking for greater than, which is this middle one. And so that's why our answer is -5 to -3 as our solution set. All right. Questions, questions, questions. So once again, the process is very similar in every scenario or each scenario out of this section. You set one side equal to 0. Then you want to, find your solutions for when it is equal to 0. That helps you set up your intervals, fill out the chart, and then go back and make sure you're answering the question. Are you talking about positive, when this expression is positive or when it is negative? All right. So those are your scenarios. Try these out. See if you get stuck on any of them. Next class, we're going to do 3.7, which is our last section out of chapter 3. So that section is relatively short. As a matter of fact, let me go up here. Yep. So this is how we're looking at next week. That section is relatively short, so you will have room to ask for questions on Monday, and then we're going to set aside Wednesday as a review day. So I will not be doing any new material on next Wednesday. You'll be able to ask whatever questions you want to ask on that day as well. Somebody last class asked about 3.2 homework. You can do it for extra credit if you like. Hold on 1 second. Sorry guys, I had to sneeze. All right, so next class we're going to talk about how we're going to do this test. I'm gonna have all the details and everything like that. So we'll talk about that on next class as well. Questions on anything I've said today? I know Mr. Coley had a question he wanted me to look at. Anybody else before I get to his question? All right. So as far as new material is concerned, I have no more for today. If you want to stick around for his question, feel free to do so. If not, I will see you next class. Have a great weekend and be safe.
Thank you, Professor. Have a good one.
All right, thank you. You do the same.
Stay safe.
You do the same. Mr. Coley.
That's Tucker.
You said you had a question on something.
Yeah. But I got another question I need to ask you that's outside of math.
Okay.
Are we alone?
Nope. So you can ask me offline at other times. Like if if it's a personal one, it's all good. The solution set that's in the book. Okay, so you said no, example 2 on page 97, excuse me. Example 2, where are we? Making sure you said now I know you said notice you said in the ebook list all possible rational zeros. That's what we're talking about.
I don't understand what are the points? What are the sets?
Now what you mean? Now in example 2?
Yeah, I know how to solve the problem, but what's the set?
What you mean by you say what's the set? Okay, hold on, let me see. There are 16 possible rational zeros, the actual solution set of. Okay, so let me write this down, and then got 15x cubed plus 14x squared. That's what we get 2 minus 3x minus 2, and then you got -1, -1/3, and 2/5. So they call that's your actual solution set. It's just a set of answers.
How do I get that?
Well,
I know 15 is 3 times 5.
mhm.
I know 2 is 2 times 1.
Now what they did first was they asked you to find all of your possible rational zeros, right? So the first thing we would do is find the constant. The constant is 2. So the factors of 2 is just 1 times 2.
It'd be at the top, it'd be plus or minus 2, at the bottom be plus or minus 1, right?
Well, we got to get the leading coefficient factors, which is 15. So you got to do 1 times 15, 3 times 5. Now you're going to take each one of these and place it over each one of these. So you put it constant over your leading coefficient. So that'll be plus or minus 1 over 1, 1 over 15, 1 over 3, and 1 over 5. And then 2 over 1, 2 over 15, 2 over 3, and 2 over 5.
And that's what I did.
And that's correct. Now, those are your possible solutions. Now, you know all of these are not your solutions, but those are the possible rational solutions. Okay, so that doesn't include if they're an imaginary or irrational. So, what you would do in order to figure this out is you can either best way to do it is to do synthetic division, because that way you'll have the breakdown of your equation. So you can take this, and you see we have two solutions here, and positive 1 and negative 1. So you can take positive 1, put it in the box, and then take your coefficients. We have 15, 14, negative 3, and 2, and do synthetic division. If it's a solution, you know we'll get 0 right here. So you bring this 15 down. 1 times 15 is 15. Add these together, it's 29. 1 times 29 is 29. Add these together, that's 26. 1 times 26 is 26. Add these together, that's 28. So we know positive 1 is not a solution. All right. Then we could do negative 1. One times 15 is negative 1 times 15 is negative 15. Add those together. That's negative 1. Negative 1 times negative 1 is positive 1. Add those together is negative 2. Negative 1 times negative 2 is positive 2, and we get 4. Hold on, did I? Oh, that's a negative 2. Sorry about that. That's a negative 2. So right here, just going back and making sure I do the nice groups right. So that's going to actually be 24. And since this is negative 2, we get 0. So because I get 0 right here, that means I have a solution. So the first solution I found is negative 1. Now I can take this and set up the breakdown, or what's left from my equation. 15x squared minus x minus 2. Remember, you always start off 1 degree less than what you originally had. Remember, we had x cubed. So now we start in x squared right here. Now I can solve this by either factoring or using my quadratic formula.
I've realized you have to use your quadratic formula for that point.
Yeah, you can use either or. I think this is factorable. Let's look at it. 3x, I believe it's factorable. Yeah. Nope, I needed the 2 to go right here. Negative and positive.
And this will give me my solution set.
Set both of these equal to 0. And once again, if you use the quadratic formula, you still got these numbers. So it just depends on what way you want to do it. Those would be your 2 answers. And I believe that matches what he said. The answers, what was it? Yeah, right here, negative 1/3 and 2/5. So I got my 3 answers.
Thank you, Professor.
Not a problem, sir.
You're the man.
I appreciate it. All right, you good to go?
Yeah.
All right. So you have a good weekend, sir, and I'll see you on Monday.
Yeah, another class right after this.
Yeah, in a few minutes or so. What's up?
I need to talk to you about something.
Okay, okay. All right. Let me go back.
In record.
Yeah, I'm trying to get to this stuff now. Let me stop it.